Okay, so for question number 4, we have the two wires that are separated by an angle of 180 degrees. We draw an x-axis at the point where they meet to the sine. They exert an equal force, so these two angles must be the same. Therefore, if the three angles must add up to 180, these two angles must add up to 180 and therefore be 40 degrees each. Good. So that sets us up for our free body diagram. The force on the right I'll call T1 and on the left T2. So we've got T1, we've got T2, we've got FG going down, we've got T1Y, we've got T2Y, T1X, T2X. Again, F net 0, and Fg is 500 newtons. Xy again, so F net x is 0 equals negative T2x plus T1x. So T2x equals T1x. As per the geometry, the x component is the adjacent side, so T2x is T2 cos 40 equals T1 cos 40. And so if we isolate T2, T2 equals T1, and we're going to divide cos 40 over cos 40, so of course, no surprise, they equal each other. So we go to the y. So on the y component, we've got Fg down and T2y, T1y up. So F net is 0 equals negative 500 newtons because, of course, they are directed downwards, plus T1y plus T2y. So 500 newtons equals T1 sine 40 plus T2 sine 40. Now, a little bit problematic, but no big deal because we said T2 equals T1. So we'll solve for T1. So obviously it's doubled. So 500 newtons would equal 2 times T1 sine 40. Now it's just a matter of isolating T1, and it's the same as T2. So we're going to take our handy dandy calculator, and we will take 500 divided by 2 divided by sine 40. And you get 388.93. And we'll take that to the whole number. So T1 is 389 newtons, and T2 is 389 newtons. And it's solved.